So that's just like saying, the example I have in here is a flat screen TV, and we're talking about frame rates. When I'm going to look for a brand new TV, I'm trying to get the TV with the highest frame rates, right? Because right now, I'll say that the frame rates are about 240 hertz. That means I'm getting 240 frames per second, or 240 hertz. Because when we're talking about the frequency of frame rates, that's going to be in frames. That's the event for TVs, is frame rate. Okay, so in that case, we're going to have 240 frame rates per second, or 240 frames per second. All right. So just remember, hertz means events per second. Okay, events per second. But our event in diagnostic ultrasound are cycles. Okay, our events in diagnostic ultrasound are cycles. I just want to clear that up. I don't want you guys to be confused and think that hertz automatically means cycles per second. It means events per second. All right. Another example would be a heartbeat. Usually, when you measuring your pulse or something like that, you usually say, you can say my heartbeat is 60 hertz. You can use that, right? That means that my heart is beating 60 seconds per minute. Okay, it's like a event over time, event in a certain duration of time. Okay, that's what hertz are.
That means when we say the hertz, it should be 1 second, not other period. Not
it's events over a duration of time. That's what hertz is.
Okay.
Events over a duration of time.
So,
Okay. So let's talk about these frequencies right here, guys. They're already telling you how frequent these waves are occurring. So this is all. See the time right here, guys. This is 1 second. 1 second right here. So right here we have 30 cycles per second. This 1 second right here. I'm not going to go and count every single cycle, but I'm going to trust that this illustration is accurate. So 30 hertz right here. This is 20 hertz, and this is 10 hertz. Can we determine the period by knowing that by knowing the frequency?
Yes.
Yes, we can. Yes, we can. So can somebody tell me what is our period? What is the time it takes to make one cycle based on this illustration on the bottom? 1 divided by 10. 1 divided by 10. Okay. So 1/10 of a second is our period. Okay, for this one.
That's not really a 0.1, because it's keep increasing at 0.1.
What's that? This? Yeah, that's 0.1 seconds. Yeah, 0.1 seconds. That's what you see it. It kind of telling you right here.
So there's two waveforms in the 20 hertz per 1 second are for 0.1. How many waveforms are in the 20 hertz?
How many waveforms are in the 20 hertz?
Yeah, in the 0.1 second. 0.1 second
We're gonna end
right there. So how
Right
many there? Is it two?
1, 2.
Okay. I'm just trying to figure out how did you get that figure? 110.
Oh, I got it. Just because I know how many seconds and I know how many hertz it is, how many cycles are occurring in that 1 second. Okay, so I can just divide the number of cycles by the time. By the time.
0.1, what is that? What are you trying to figure out?
The period of this wave of this this cycle, that period it occurs in 1/10 of a second. 1/10 of a second. Okay, and in this one right here. All right. Ooh, snap. Okay. So guys, we're gonna kind of group our next 3 parameters together, and these are also known as our bigness parameters, guys. Our biggest parameters are going to be amplitude, power, and intensity. Okay? These parameters are going to describe the size, the magnitude, and the strength of a sound wave. size, the magnitude, and the strength of the sound wave. All right. And again, those three are going to be amplitude, power, and intensity.
So the amplitude means the size.
All of these, they're describing all of those things: the size, the magnitude, and the strength.
No,
Remember,
I mean, as a definition, like amplitude means stands for the size.
no, I'm going to come to it right now. I'm coming. These slide at me. But that's what these are describing. These are all, they can be, I don't want to say they're all synonymous, but they're all describing how high, for instance, it comes up on the y-axis. The strength of that sound, the magnitude, the bigness of that sound, okay? How big that cycle happens to be. All right? Amplitude is the bigness of a wave. So if we're looking at these my two cycles right here, guys, which one would you think is bigger? My higher frequency or the lower frequency? This is by my illustration. My higher frequency is a bigger sound wave. They have a higher strength, higher amplitude. All right? It has a bigger size. Okay?
That means like how maximum is gonna go.
Absolutely.
Okay.
Absolutely.
Okay.
Absolutely.
So because this is lower, the other one is higher, so that's why that's higher amplitude.
Mm-hmm. Mm-hmm. The bigness of that wave. This wave right here is a small wave in size compared to how big this wave is, how big it is. All right? So that's the difference between the maximum value and the average or undisturbed value of an acoustic variable. That's just saying that's the maximum to the zero on the graph, okay? That's what the undisturbed or the average value is, okay? That's the maximum to the zero, okay? And just the opposite. Amplitude is also just the opposite. It's also the difference between the minimum value or our trough, right? The minimum value and the average or undisturbed value of an acoustic variable. So it's either going to be the peak all the way to the baseline. Remember, our baseline is our x. That's our zero, right? So it's going to be the peak to the baseline, or it's going to be the baseline to the trough.
Trough means down.
Down. Down. The trough is the bottom of it. So this right here, this is the trough. This right here, that's a peak. That's a peak right there. All right? So it's going to be either way. Either way, okay? Amplitude can have units of any of the acoustic variables. We already talked about our units of the acoustic variables. One being distance, which is any distance, centimeters, inches. P for pressure would be pascals. That's the unit. And also our one for density would be grams per centimeters cubed, or in our case, kilograms per centimeters cubed. Okay? Weight, concentration of mass over an area. Okay? That's what density is. All right? But the units they use for amplitude, in our case for diagnostic ultrasound, is going to be in decibels. All right? It's going to be in decibels. But I'm telling you, it can be any one of the acoustic variable units. Okay? Any one of the acoustic variable units. Because remember, acoustic variables are measured in oscillations. Okay? The typical values range from 1 megapascal to 3 megapascals. I'm sure they're using these numbers to simplify them, right? They're trying to make them more readable, okay? Because they could just say 1 million pascals or 3 million pascals. Okay, that's what that is. Okay. This is also determined by the sound source, okay, from the machine and the transducer. Amplitude, because of attenuation, right? We know the strength of the beam is going to lose strength as it propagates. As sound travels, it's going to lose strength, right? And that rate depends on the characteristics of both the wave and the medium, okay? Because sound travels at different speeds in different mediums, and that's going to affect the amount of attenuation, okay? Or the rate at which energy is lost over time, okay? The amplitude is adjustable, guys. The amplitude is adjustable by us. One way we can adjust amplitude would be, again, when we're changing this, when we use this button, we're changing all of the bigness parameters. when we change our acoustic power, remember I showed you guys that button on the machine? Acoustic power, we're changing the amplitude, we're changing the power, we're changing the intensity. Okay? That acoustic power button, remember we showed you guys that? If you click on the next screen, on the touch screen of the IU-22, you can change the output power. Remember, that's another term for acoustic power, output power. All right? So yes, so that's the key, guys. Our three bigness parameters are all adjustable. We can adjust as technology. We're able to adjust them. All right? We're able to adjust them. All right? So, this is amplitude right here, guys. So remember, this is our undisturbed value right there, or our zero on our x-axis right here. So it's going to be from the peak to the undisturbed value, okay? Or it can be from the undisturbed value to the trough, okay? Just one way, okay? Amplitude is measured from the baseline to the maximum, or from the baseline to the minimum value, okay? That's just one way. That's going to describe our amplitude, okay? It's a difference between our amplitude and our peak-to-peak amplitude, and the peak-to-peak amplitude is the difference between the maximum and minimum values. So it's safe to say that our peak-to-peak amplitude is always double the amplitude, right?
Mm-hmm.
Correct? All right, our peak-to-peak amplitude is always going to be double the amplitude. All right, or twice the value of the amplitude. Okay? Remember, this is adjustable when we change our acoustic power, guys. We change our acoustic power. Okay. I'm gonna stop right there, guys. I'm gonna stop right there. Because y'all read, I do have something for you guys to do. I do have a little quiz for you guys. So please clear your desk. Let's do it. Let's do it. Let's do it today. All right. What's you for good, President? POTUS, President of the Ultrasound